2018 number 4 part C, it says use a trapezoidal sum with 4 subintervals to approximate the average height of the tree over the interval 2 to 10. So before you get hung up in how to doing the trapezoidal sum, let's start with average height of the tree. So, maybe think average height, I would sort of think of this first, is 1 over b minus a times the integral from a to b of h of t dt. So I would start thinking about that. So that's, by the way, equal to 1 over 10 minus 2 times the integral from 2 to 10. Yeah, you probably don't have to write this part. But writing, I think, either one of these might be worth a point. So I'm just writing out a couple of things. If you wrote any one of these things, I think it might be worth a point. I haven't looked at the scoring yet. Okay, so now we got to do, so this is what we need the trapezoidal sum for. We need a trapezoidal sum for this. So look, you can use formulas and things, but one of the things to really watch out for that a lot of people get trapped by, the delta x is not constant. Whereas from 2 to 3, that delta x is 1. From 3 to 5, that delta x is 2. 5 to 7, we have delta x equals 2. And 7 to 10, we have delta x equals 3. So in terms of some of the formulas we've used for this, it's not going to work very well. The table doesn't work very well because of the different delta x's. What really works well for me is to just sketch a graph of this. So I would just, make a little sketchy graph. It doesn't have to be a super accurate graph. I try to keep it, vaguely proportional. Like here's 2, here's 3, here's 5, here's 7, and then here's 10 over here, like vaguely proportional. And then I have 1.5. Typically what I do is I just put a value over the point so that I know what the value is without having to line it up with I guess this is 2 actually. Not having to line it up with a y-axis. And then for 5 we have 6, so this is going to be 6. And then for 7 we have 11. We have 11 up here, and then we have 15. And then see what I do is just, because they're always going to do this, they're not going to ask you to do 10 intervals. They're going to ask you to do 3 or 4 intervals. So then, I just draw the trapezoids in. It just helps me to not get lost. And then it's really easy to go, right, here's my trapezoid 1, trapezoid 2. You can call them A1, A2, and A3 if you want for areas. I'm calling them T's for trapezoids. And then you just have to remember that your area of a trapezoid is 1/2 the height times b1 plus b2, and the height is actually going to be here. The height is actually delta x. So this delta x, that's actually your height. So that gives me the first trapezoid is 1/2 times 1. I'll put in the times 1 times 1.5 plus 2, and then the second one, trapezoid 2, is 1/2 times, my delta x this time is 2 times, and this time I'm doing 6 plus 2, right? This is my b1 plus my b2. I guess I put them in different orders, which is slightly sloppy, but doesn't affect the result. For my t3, it's 1/2 times the 2 here. So this time I have 11 and 6 for my b1 and b2. And then for my t4, I have 1/2 times, and this time the height of the trapezoid is 3. The delta x, which is the height of the trapezoid, is 3. I have 15 plus 11. All right. Now, by the way, this was a no calculator problem, so they expected you to do all this by hand. Of course, we probably don't have to worry about that this year, but this is 1.75, this is 8, and you can work those out, it's just arithmetic, 39. So if all we were asked for is the trapezoidal sum and we didn't have to do this, I would probably not even bother to add these up. I mean, if you want, in fact, you can say the average height equals 1/8 times 1.75 plus 8 plus 17 plus 39. And you actually have it right there. That's full points for writing that. It's a little awkward, and it makes you write. So you have to decide what's worth more, having to add all these up or having to write them down. I guess it's probably easier just writing them down. So this is probably your best, most efficient response, but by the way, that happens to be equal to 1/8 times 65.75, and that happens to be equal to 8.219. So there you go. That is the average height of the tree over 2 to 10. And I don't think we have to say anything else about that. It just says approximate the average height of the tree, and we did that. It doesn't say anything about units or interpreting or anything like that, so we can just leave our answer 8.219. I mean, it'd be nice to put units on. It's meters, but you won't lose points if you don't, because it doesn't say anything about units in the problem.